Hey everybody, this is Larry. This is day 2 of the June Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's problem, and welcome if you're new. If not, that's fine too. Let's just, enjoy this problem and join me on Discord. We could chat about it or other problems, whatever you like. Today's problem is going to be interleaving string. So, okay, given 3 string, find out whether S3 is formed by interleaving of S1 and 2. Does it have to be in any order? Nope. So this seems relatively excuse me. Wow, I don't know. I just had water. But okay. So it's not like it's a perfect shuffle type situation. This is just that, just to see, yeah. The tricky thing will be just to see if you can do it with you know, how I would solve this is just dynamic programming as a short story. And part of that sometimes, and the trick. I don't know why I say a lot, but the tricky part about that is that you're just trying to do an exhaustive search, but caching results along the way. That's how I would think about this in terms of memorization. And yeah, and I think that's pretty much it. And there are a couple of ways to do it, of course. I think the way that I would, I'm going to do it recursively, and I know that there's the follow up. You could do it in in uh, in one of the O of two extra space, but that's just way standard dynamic programming space optimization that I'll put a link below, but I'm probably not going to do it that way because yeah, I don't know. Maybe today I'm just a little bit tired. I say that a lot, but to be honest, it's because I usually do these at 3 a.m. because I don't know. They could release these at 3 a.m. and sometimes I do it a couple of hours later when I wake up, and I'm still tired because I just woke up. So, okay, that aside, um, let's just say we have a can interleave function. So the way that I would also say is that you keep as these 3 things, and I don't know what I'm saying, but let's see. So I'm just trying to see if they check on the length, but yeah. So if I guess we can do something like this real quick. Return false. Otherwise, and I am going to actually change this so if you already know dynamic programming or memorization, this will look really awkward for you. But let's say S1, S2, and S3 are strings, and these are the suffix of the string, right? So we want to answer the question of, can the suffix of S1, well, this question would be, can S1 plus interleave S2 equals S3, something like that, right? So that's what this function would answer. But the thing to notice is that look at all the possible inputs to this S1, not to be confused with this S1. This S1, all the possible inputs are suffixes of this S1, right? And how many suffixes are there? There's 10. Or sorry, I don't know why I said 10. Man, I'm a little bit off today. The number of suffixes here are n, right? N different number of suffixes, where n is the length of S1. And you can kind of denote which of those suffixes you want by a number, which is the index you start that suffix with. Meaning that, if you have index 0, you have the entire string. If you have index 1, you have the entire string minus the first character. You have index 2, and so forth, right? So in that way, and you see people do this, then you have index 1, index 2, and index 3. In the same way, you can extend that to index 2 and index 3. As a fun fact, as a fun game at home, I think I'm trying to be better about not. I don't know why I have all these pause words or whatever filler words, where I say a lot. So if you're counting, it's a little bit late now, but in the next couple of weeks, count the number of times I say and leave in the comments, and I'll give some, I don't know, have something fun for the fans who are actually counting. And I'm trying to get it down, so hopefully one day the answer to that will be 0. Anyway, unrelated, but yeah. Okay, so and also I would also say that even though we have these 3 inputs, notice that index 3 will always be index 1 plus index 2. Maybe it's not quite clear now, but we'll get to that in a little bit. So in that case, we can just remove it and go index 3 is equal to index 1 plus index 2, right? You could kind of think about it as pointers. Every time you move index 1, you move index 3 by 1. You have to. And every time you move index 2 by 1, you move index 3 by 1. So that's basically the short story. And if index 3 is equal to, let's just say L3 maybe, N3, I don't know, S3. This is now awkward because now I do it twice. But yeah, fine, let's just do it for all. Everyone gets a variable. But yeah, if this is at the very end, then we can return true. That means that, because by default, that means that we have empty string for index 1 and empty string for index 2 and an empty string for index 3, because that's the suffix of S3. Okay. So now we only have a couple of cases, right? If index 1, if S1 of index 1 is, well, let's also check that index 1 is less than N1, and this is equal to S3 of index 3, then, well, if they match, then this can be true. It doesn't have to be true, but it can be true. So yeah, so N can interleave of index 1, and if they, and as I said, if you want to match the first character of S1, the current prefix of S1, the first character, then this, you move that up by 1, and you index 2 just keep the same in this case, and you also move index 3 by 1. And if all those 3, if that condition returns true, you just return true, right? If same thing for index 2, you can kind of get the idea here, hopefully. If not, maybe draw it out a little bit, just one character at a time. And this is pretty standard dynamic programming. After you get the logic, yeah, it becomes a lot easier, which I guess is true for anything. And if neither of those are true, then you return false, or in my case, false. But yeah, and that's pretty much it. And to start it off, you do can interleave 0 0. Yeah. And that's pretty much the answer. I know that I'm skipping the memorization for now. So those of you at home, no worries, I'll get to it. But the inputs here should be small enough to kind of just to 1, I believe. Maybe not. We'll see. It should be though. We'd be surprised if it's not. One thing I would also note as a competitive programmer, I guess. I mean, I don't know. Even just calling myself, that sounds a little bit awkward. But as someone who has done that in the past, one thing that I would point out is that because the answers are true and false, there is a little bit risky that when you wonder, okay, well, oh, I forgot that I took out the index 3, so we don't need that part. Whoopsie daisies. But in any case, notice that the answer can only be true and false, so it's a little bit because if you only give a couple of handful of inputs, you may get quote unquote lucky and have check the answer and like, oh yeah, it's right, but then you submit, it still could be wrong. So if you want to avoid the WA, the wrong answer verdict, you have to really be more confident, or if the code is something that you've done enough times, right? So yeah, so of course, this looks good, blah blah blah. But given that n is 100, let's say all the characters are the same, right? They're all A's. Say that means that this is gonna run and this is gonna run, and let's just say it's all A's except for at the very end, there's like a B or something. So basically, it branches out every possible way. And in that case, it's gonna be exponential, pretty much. And we could probably generate this. Let's put it. What was it? 100. That's 10. 20, 30, 40, 50, 60, 70, 80, 90, 100, something like that. And that's just, is that 100? That seems a little bit short. That's what she said. Anyway, yeah, and this should time limited exceeded, which I know that I gave the spoiler way long ago, but yeah. So the short answer here is to memorize, and the reason, and this goes back a little bit to if you do it a little bit more naively, and that should be fine because conceptually, depending on how you actually cache it, if you left index 3 as a parameter, you can if you do a naive analysis, you go, okay, index 1 goes from 0 to n1, which is 100, and index 2 goes from 0 to n2, which is 100, and index 3 goes from 0 to n3, which is 200, I think, which makes sense. Yeah, in this case, you'll be like, oh, this is simply n1 times n2 times n3, which is going to be, actually, I think it's probably still fast enough, but it's still a little bit awkwardly slow. But even if you had, so if you create a 3-dimensional matrix to cache this, that would be the case in that you use all that memory. But if you actually cache it in a sparse table or a dictionary or something like that, it would actually still have the complexity that you did not, like your analysis may give you n cubed, say, or I guess it's not really n cubed, but you know what I mean. If it's n1 times n2 times n3, but actually in reality it would still only give you n1 times n2 space complexity, because there are a lot of impossible states that you do not reach, even though it does not appear that way. For example, index 1 is equal to, I don't know, 12, index 2 is equal to 25, say, index 3 is equal to 2. Well, that's not a possible state, so you will never find that state in the dictionary because it's not reachable, right? So that's basically the thing here. And for that reason, this is why you can remove index 3, because it has no relevance to, and because you can derive that from index 1 plus index 2, and without any loss of information. So anyway, so yeah, if you look at that, then it becomes clear that you can remove this, and the space. Ooh, excuse me. Yeah, so the number of possible inputs is now n1 times n2. For each one, we do at most 2 branchings, but they're all constant operations, like a handful. So time is going to be O of n1 times n2. Space in this case is also going to be O of n1 times n2, if you cache it, which we will. But I forgot to do that first. Whoopsie. So yeah, so cache is equal to force times n2 for, n1 has cache. Same thing. I guess I could copy and paste, but it's fine. I type very quickly, maybe. Yeah, and then now, actually, yikes, typo. Well, not typo, but off by 1. Because we want to go from 0 to n plus 1 exclusively, or inclusively. I guess you don't have to, but maybe I think it makes things easier. In any case. So yeah, so if has, this is how I usually teach it, because it looks pretty straightforward, and it's not that hard. I know that a lot of people just do the memorization decorator, especially in Python, but I mean, you can see that it's, for the most part, pretty easy to write, right? So yeah, might have to change things a little bit. Uh, yeah, that part's a little bit awkward. Not gonna lie. And I would say that it is pretty generally pretty easy to kind of do this. Um, I know that it's probably a little bit more error prone, but on an interview especially, you can kind of go what is next step, which is that you look at the space and you go, okay, well the space is here, so it's obvious what the space is. So this is, as I said, it's gonna be of n1 times n2 time and n1 times n2 space. Oh, I guess I should like run it real quick just to show it. That would be awkward if it doesn't finish. Well, it gives me a time limit exceeded anyway. Oh, whoops. This should be. I got a little lazy to copy and paste. But this should be true. We don't have to up. I guess we'll update it explicitly, even though that is the default value. Whoopsie. That's why you still test your stuff. But yeah, now it finishes very quickly. Gives us this false, and let's give it a quick submit. Hopefully, I didn't miss any edge cases, and it looks good. But yeah, so time, as I said, is n1 times n2, and space is going to be n1 times n2. And the follow-up question is, could you solve it using O of s2.length, which is n2 in our lingo, additional memory space? And the answer is yes. So the first thing you do is you would rewrite this to be bottoms up. And then notice that index 1 and index 2 only depends on the last thingy and yada yada yada. You could do the space optimization there. I solve the space optimization thing from time to time. Today I'm not going to do it, but I'll have a link below because I think this is pretty straightforward to do. And yeah, if you haven't done it before, I definitely recommend practicing and upsolving it and stuff like that. It comes in handy in certain cases, and also just gives you an understanding on different ways of dynamic programming in general, which for different scenarios it comes in handy, or maybe even necessary. But yeah, I'll send a link below, or someone from the chat can, for my dynamic programming space optimization progression guide. But yeah, but that's all I really have for this one. Let me know what you think. Hit the like button, hit the subscribe button, join me in Discord. Have a great night. Have a great rest of the week. It's already Wednesday, I guess, because Memorial Day and stuff. Yeah, stay good, stay healthy, to good mental health, and I'll see you later. Bye bye.